This is a closed system that keeps all the factors of production and the goods and the counter-performance of payments within the closed loop. We can use this same closed system to start off our discussion of the simple Keynesian model, which excludes government and the foreign sector, but does make use of saving and investment. In a closed system such as this one, aggregate spending equals total income. All production is sold to the households. The households use all their income to purchase the production of the firms. Here we have aggregate spending, for which the symbol is A, represented on the vertical axis, and income, with symbol Y, on the horizontal axis. In terms of our closed economy, income is equal to production, so the x-axis is also used to represent aggregate production. So by drawing both axes to the same scale, a 45-degree line from the origin would represent all the possible equilibrium positions between income and spending. For any point lying on this line, income would be equal to spending. The expression representing this line would in fact simply be A equals Y. Any point above this line would represent excess demand, consumption being higher than production. A point below the line would indicate excess supply. Production, reflected on the horizontal axis, would be greater than consumption. The consumption function is made up of two components. There is a part of consumer consumption that will take place irrespective of the level of income of the household. This is referred to as autonomous consumption or dis-saving. When a household has no income, it must survive on its savings. So this autonomous consumption that takes place irrespective of income comes from savings. Total consumption is referred to as C. The term used to represent autonomous consumption in the algebraic expression is bar C. So the first part of our expression for consumption is C is equal to bar C plus. On our graph, this would be represented by a horizontal line. This autonomous consumption will remain constant irrespective of the level of income. The second component of the consumption equation represents that part of consumption that is driven by income. The higher the income, the more will be spent. The second part of the equation is referred to as induced consumption and is represented by the term CY, where Y represents the level of income and C represents the portion of income that the households will spend. C must therefore always be less than 1. This fraction is referred to as the marginal propensity to consume. The marginal propensity to consume represents that part of a household's income that it will spend. That which is not consumed is saved. If C is deducted from 1, then we have that portion of income that will be saved. The consumption percentage plus the savings percentage is always equal to 100%. So the full consumption function looks like this. C is equal to autonomous consumption plus induced consumption. And its graphic representation is this. Autonomous consumption indicates where the consumption line intersects the vertical or aggregate spending axis. The marginal propensity to consume represents the slope of the curve. The curve here represents a marginal propensity to consume of 0.7. The slope becomes steeper as the MPC increases until it reaches a maximum value of 1 when it is parallel to the 45-degree line, which signifies that no income is being saved. It is all spent. With an MPC of 1, each additional unit of income that is earned is consumed and nothing is saved. Let's return to a position where our MPC is equal to 0.8. Let's further assume that the level of autonomous consumption is 20. The consumption function now looks like this. We now move on to saving and investment. The savings function can be deduced from the consumption equation. We said that the autonomous consumption of 20 is taken from savings. The savings function therefore must start out with the same amount, but as a shortfall or minus value. It is therefore actually a dissaving of 20. If the marginal propensity to consume is equal to 0.8, then in terms of the assumptions of our model, it follows that 20% or 0.2 of income is saved. So the second part of the savings function reflects just that, 20% of income being saved. This is what the savings graph looks like. Savings represent a withdrawal from the system. Investment is the corresponding injection, which we now move on to. Investment spending is also independent of income. It's autonomous, and so it is represented by a horizontal line parallel to the income axis. For the sake of our discussion, we'll assume it to be 50. The expression for the investment function is simply that investment is equal to autonomous investment. Looking at our model from the point of view of spending, we have now defined consumption spending as well as investment spending. The aggregate or combined spending is equal to the sum of these figures at each level of income. For the moment, we can therefore remove the consumption function and the investment function from our graph as they are combined in the aggregate spending line. If we now put back our 45-degree line, which shows all the points of equilibrium between income and spending, that is where aggregate income is equal to aggregate spending, we should be able to establish what the level of income is that will support the figures that we have incorporated into the aggregate consumption line. The first assumption was that autonomous spending is equal to 20. The second was that investment is equal to 50. So the intercept of the aggregate spending function with the vertical axis must be 70. But let's get back to our aggregate spending line and the point that it intersects with the 45-degree line. At equilibrium, A is equal to Y. Therefore, we could write the formula as aggregate income is equal to consumption plus investment. We can now replace C with the consumption function. Autonomous consumption plus the marginal propensity to consume times income. Now we can replace the known variables in the equation. Autonomous consumption expenditure of 20, marginal propensity to consume of 0.8, and investment expenditure of 50. That reduces to 0.2y equals 70, and therefore y equals 350. So the equilibrium level of income, and therefore of aggregate spending, is 350. We should be able to confirm this equilibrium level by testing it against the savings and investment functions and the level of income where they are in equilibrium. That is, where savings are just sufficient to finance investment expenditure. Here we have the savings function together with the autonomous investment line. The point at which they intersect is where savings would be just sufficient to fund investment. Going through the calculations, we find that the level of income is 350, which bears out the conclusion we came to when looking at the aggregate spending curve. Government is the next element we wish to add to our Keynesian model. The levying of taxes was seen as a withdrawal from our closed flow, and government spending acted as the injection back into the economy. When we look at taxation, we will notice that the model regards taxes as a function of income. Once having levied the taxes, the actual spending in the goods and factor markets by government is regarded as being an autonomous action, just as investment and the autonomous portion of consumption spending. So, looking at government spending graphically, the curve looks like this: a horizontal line indicating that the level of spending is unaffected by the level of income. Exactly the same as the autonomous consumption function or the investment function, but naturally at a different level of spending as measured on the aggregate spending axis. We now want to look at how the equilibrium level of income is established once government expenditure is included into the model. We start out with our basic equilibrium function, y equal to a. Any point on this line indicates that aggregate income is equal to aggregate spending. Then replace A with its components: consumption, investment, and now government expenditure. The last two, investment and government expenditure, are autonomous. That is, they are not dependent on the level of income. Consumption can now be replaced with its two elements, namely the autonomous consumption part and induced consumption. Induced consumption has two components again: the marginal propensity to consume and the level of income. We bring the elements that are related to income, or y, over to the left-hand side of the equation and take out the common element y, leaving us with y into 1 minus c on the left-hand side. All that remains is to divide by 1 minus c on both sides of the equation so that y remains on the left-hand side. And we're left with a familiar element of the multiplier times autonomous expenditure, which now includes government. So the equilibrium level of income is equal to the multiplier times total autonomous spending. Total autonomous spending is made up of autonomous consumption spending, investment spending, and government spending. The expression can be abbreviated to alpha times bar A. But the model still does not include the levying of taxes. We have only included government spending at this stage. The question now is, how do taxes affect spending and income in the economy? Just to recap, the first element of government activity that we included into the model was government spending, which is classified as autonomous in the model. This moved the aggregate spending line upwards in order to reflect this additional spending. In the process, the equilibrium level of income increased from this level to here. In South Africa, the tax burden is made up of direct and indirect taxes. In the model, taxes are regarded as being levied at a fixed rate, notwithstanding the fact that our personal income tax is a progressive tax. The proportional rate can be thought of as the total tax levied over the fiscal year divided by the total taxable income recording for that year, which then gives an average tax rate. Tax remains, however, a function of income. The first impact of tax is that it reduces disposable income. After tax has been paid, the households have less disposable income. We therefore need to make a distinction between total income and disposable income. The relationship between the two can be depicted like this. Disposable income is equal to total income minus tax. But we also know that tax is a function of income. So we can write the formula as disposable income is equal to y minus ty, where t is the tax rate. This then converts to 1 minus t times y. Our consumption function says that aggregate consumption is equal to autonomous consumption plus the induced part, or MPC times income. Based on what we know about tax, we must now revise this consumption function to reflect the reality that consumption must be based on disposable income. The term income must be replaced with disposable income. But disposable income is equal to 1 minus t times y. So this is what the consumption function becomes, with a slope of c into 1 minus t. This is our original consumption function with a slope of c over 1. By including tax in the model, the consumption line has a flatter slope of c into 1 minus t over 1. Looking at this process graphically, we have the autonomous government spending line, which causes the consumption function to move up by the same value. This moves the equilibrium level from here to here. But once taxation has been brought into the picture, the angle of the consumption curve becomes more shallow, and the final equilibrium income level is established here.